Now, in this video, we're going to go over one example where rotational momentum is not conserved. So, without further ado, let's just take a look at this problem. Here we have a spinning stool where a student decides to give it a push. The student applies a force of 3 newtons perpendicular to the edge of the stool, which has a radius of 0.4 meters for a duration of 0.2 seconds. Determine the final angular momentum of the spinning stool if it begins from a stationary position. So its initial angular velocity is 0. All right. So in this case, of course, the angular momentum is not conserved. Why do I say of course? Well, the stool is not rotating, right? Its initial rotational velocity is 0, and then it begins to rotate. So therefore, it attains some momentum because it attains some velocity. So just the same way how we define impulse in linear motion, that is, we said that if you apply a force over some time, you can change the momentum. We can say that if you apply a torque over some time, you can change the angular momentum, right? So let's figure out what each of those is. So torque is equal to, now LF is what we need to find. Torque is equal to force times distance from which it's applied, so which is the radius of the rotation. We're also given the time, and we know that initially angular momentum is 0 because this velocity right here is 0. So therefore, torque is force times R times T, right? This cancels out to 0. So plugging all of these units in, force is 3, R is 0.4, T is 0.2. So therefore, we have a final answer of 0.24 in the units, right, of newtons times meters times seconds. Great. Right, because again, we have force times meters times seconds. So again, angular momentum doesn't have any special units. Okay, great. So now that we find our final angular momentum, in part B, we have to find final angular velocity. So we know that momentum is equal to I times omega. And here in this example, we can assume that I, which is the moment of inertia, is 1/2 mr squared. Right? You can basically assume that the stool is a solid wheel, right? Or a solid disc. Typically, I should have given you actually I in the problem. So don't worry if you didn't recall this equation, right? Because it either should be given to you directly in the problem or separately on an equation sheet. So this is something that you would know, that I is equal to 1/2 mr squared for this specific example. So we just rearrange our answer for L final over 1/2 mr squared, or omega final is LF was 0.24. That's we got from the previous part. 1/2 times mass, 10 times radius of the rotation, 0.4 squared. So we have a final answer of 0.6 radians per second. Great. Well, thank you guys for watching. This concludes our review of the rotational unit, right? But remember that I have the videos that cover every unit in physics, and furthermore, right, I will create one big video that will describe how to approach any problem in physics. So we'll go over literally every single topic in one pretty short, concise video. So keep watching and keep practicing on your way to an A. Thank you guys for watching.